This recording of parallel and perpendicular lines is part 1 of the day's lesson. And so what we will do is just start off with some new theorems. And you can come back after the lesson and fill in your essential question. Our first theorem doesn't have a name, so when you use these theorems in proofs that don't have names, you just have to paraphrase the theorem in as few words as possible. I know that's a bit of a pain, but some theorems just don't have names, and you can't just label them with the numbers that are in the book, like Theorem 3-5, because every textbook writer labels them a different way. So unfortunately, they don't have names, so we'll have to paraphrase them when we do use them in a proof. All right, if two lines are parallel to the same line, then they are parallel to each other. That makes pretty good sense. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So look at your figure here. M is perpendicular to P. N is perpendicular to P. Therefore, I know that M is parallel to N. And finally, we have the perpendicular transversal theorem that says if a transversal is perpendicular to one of two parallel lines, so if I know that H and K are parallel, see they're marked here, and if I know that J is perpendicular to H, then I know that it also has to be perpendicular to K. So if it's perpendicular to one of two parallel lines, then it's got to be perpendicular to that other line. All right, so let's just hop right in here and try to do a quick proof. You're building the picture frame in the diagram below. You cut pieces of wood such that the measures of angles 1 and 2 are, angles 1 and 4 are 30 degrees, and the measures of angles 2 and 3 are 60 degrees. Prove that the right and left sides of the frame are parallel. Okay, so how do I remember if I'm trying to prove that lines are parallel, I have to use those converses that we learned about in the last lesson. So my last step is going to say that probably what I want to say in my last step, I want to prove that the right and left sides are parallel. So let me just write myself a note here. I'm trying to prove that PS is parallel to QR. Okay, so that's going to be the last statement of my proof. And how am I going to do that? Well, I'm going to have to use one of those theorems. Or, well, I could actually use one of these theorems above. I don't have to use one of the converses, so sorry, I take that back. What I'm thinking is I'm going to use one of these 3 theorems that I just told you about. So let's just start, and I'm probably going to run out of room here, so I hope you have some room at the bottom of your paper as well. So my statements, my reasons, and let's see, I'm going to start with the given. What do they tell me that's given? Well, I know that the measure of angle 1 and the measure of angle 4 are each 30 degrees. And also, I know that the measure of angle 2 and the measure of angle 3 are each 60 degrees. That's given. Okay, so look at 1 and 2. Here are angles 1 and 2 here. What do I know? If angle 1's measure is 30 and angle 2's measure is 60, then I think what I know is that angle 1 is complementary to angle 2. And also I know the same things about angles 3 and 4, right? There may be a little bit different way to go about this proof. If you want to pause right here and try to do it yourself, and then we can compare our methods, that wouldn't be a bad idea. I'm going to go on down here and I'm going to say angle 3 is complementary to angle 4. And how do I know that? Well, that's the definition of complementary angles. Angles whose sum is 90 degrees, and that's given to me. I mean, I guess you could put a step in here where you say the measure of angle 1 plus the measure of angle 2 is 90 degrees, and the same thing for the other side, but I think it's okay to leave it out. If you don't feel comfortable leaving it out, then by all means put that step in there. Okay, so let's see, if angle 1 and angle 2 are complementary, then what do I know about those angles? Oh, complementary angles. Their sum is 90 degrees, so what I'm going to put here is that the measure of angle, and I'm going to call this one PST, right? That's a T, no, wait, what is that? Is this a T right here? PS, I hope it is. No, that's an R. Sorry guys, that's an R there. I couldn't see, I had to double check. So the measure of angle PSR equals 90 degrees, and also the measure of angle QRS equals 90 degrees. And I would also say that's the definition of complementary angles. All right, like I said, you may think of a little bit better way or a quicker way or a different way to do this. We can certainly talk about it in class. So what I would do next is I would say that angle PSR and angle QRS are right angles. And how do I know that? Well, because that's the definition of a right angle. Their measures, a right angle is an angle whose measure is 90 degrees, and I just said that in step 3, so I'm going to say they're right angles because of the definition of a right angle. All right, well, where does that get me? Well, where that gets me then is that I can say PS is perpendicular to SR. And likewise, I can say QR is perpendicular to SR. And how do I know that? Well, their intersection makes right angles. That's the definition of perpendicular lines. So that would be my reason there. Right, definition of perpendicular lines. And finally, in my 6th step then, I can say that PS is parallel to QR. Remember, that's what I wanted to prove. Let's look back up here. I wanted to prove that PS is parallel to QR, and I know that now. Why do I know that? Because of the theorem up there that says if two lines are perpendicular to the same line, then they're parallel to each other. So I'm just going to kind of shorthand that and say theorem, two lines are perpendicular to the same line. So whenever you need to use that theorem, it's fine with me if you abbreviate it just like that. I don't really think you can get away with saying it much more succinctly. All right. So be sure to look over that proof. If there's something you don't understand or something you don't agree with, then let's talk about it in class next time. All right. We have another problem, real life problem. In the diagram below, each fence post is parallel to the fence post immediately to the right. So 1 is parallel to 2, and then 3 would be to the right. So 2 would be parallel to 3, and then 3 would be parallel to 4. So what they want us to do is say, how come I know that the first fence post, L1, is parallel to L4? Well, let's see. What we know is from the given, we're not going to prove this, we're just going to reason it out. We could write a proof, but we're not going to. So I know that L1 is parallel to L2. That's given if you wanted to write that down. That's given. And I also know that parallel to the fence post immediately to the right, so I know that L2 is parallel to L3. So what can I say as a result of these two statements? Since L1 and L3 are both parallel to L2, then I know that L1 is parallel to L3. And that's not the transitive property, my friends. That's because of the theorem that says if a line is parallel, what does it say exactly? If two lines are parallel to the same line, then they are parallel to each other. So L1 and L3 are parallel to the same line, so they're parallel to each other. Okay, and then we know that L3 is parallel to L4 because that's what it tells us up here. Each post is parallel to the post immediately to the right. And if I put these two statements together, let's put this one down here, that L1 is parallel to L3, then what I can say, because of these two, is that L1 is parallel to L4. Why? Because if two lines are parallel to the same line, then they're parallel to each other. So that's the theorem we would use to prove that. And we could have written it as a nice proof. But we weren't asked to, so we didn't. All right, let's see what we have next. We do have a little proof here. What I'm going to do is pause the video. I'll work the proof, you work the proof, and then check back in and see how you did. Alrighty, so what we're given is that BA, so the two sides of the angle, BA and BC are perpendicular. I can see that marking there. So that's my given statement. That's statement number one. All right, what do I want to say now? Well, I'm just going to go off of that, and I'm going to say that ABC, angle ABC, is a right angle. And how do I know that? Because that's the definition of perpendicular lines. Lines that intersect to form a right angle. Okay, so I got to think about this now. What am I trying to get to? I'm trying to get to the two angles that actually make up angle ABC are complementary. So I know the definition of complementary angles says angles whose sum, the sum of the measures of the angles is 90 degrees. So I'm going to go ahead, and since I know that ABC is a right angle, I'm going to say its measure is 90 degrees. And how do I know that? Because that's the definition of a right angle. Okay, and now what I can do, now that I've got an equality statement here, I can come on in here and I can say that the measure of angle ABD, and here it is, here's ABD, that's actually angle 1, and it would be okay if you just wrote the measure of angle 1 at this point, but it didn't really occur to me till I had already written this down. So the measure of angle ABD plus the measure of angle DBC is 90 degrees. I'm sorry, equals the measure of angle ABC. Not ready to say 90 degrees yet. And that's just using the angle addition postulate. Measure of angle ABD, so that's angle 1, and the measure of angle DBC, which is angle 2, equals the measure of the whole thing, which is ABC. And then in my next step, I'm just going to substitute everything I know. I'm going to substitute the measure of angle 1 in for the measure of ABD, the measure of angle 2 in for the measure of angle DBC, and then I know that from statement number 3 I can substitute 90 degrees in for the measure of angle ABC. All that I just did using the substitution property of equality. And finally now I can say angle 1 is complementary to angle 2 because that's the definition of complementary angles. So I can't really think of a shorter way to do that proof, but if you did it in some way that is shorter and you think that you have it correct, then by all means bring it up to us in class tomorrow. Okay, and finally we have two little problems here that I just printed right out of the textbook. So what I want to do to prevent this video from going on and on too long is to let you ponder these two questions, write down what you think the correct answers are, and then we'll talk about them before we get started with our classwork tomorrow. So what you should do here is label these 1 through 5. And so what I want you to do is write down what you think you can conclude based on statement number 1. So let's do number 1 together. So we got a ladder here, and it says the rungs are each perpendicular to one side. So here are my rungs, and they're all perpendicular to one side. So I can make myself a little drawing here. All these rungs are perpendicular to that side. So what do we know about them because of the 3 theorems we learned today? I know the rungs are parallel to each other. Right? And how do I know that? Because in a plane, if 2 lines are perpendicular to the same line, so all these are perpendicular to the same line, then I know they have to be parallel to each other. So that's how you want to go. You may need to draw yourself a sketch for each one of these and then write down what your reasoning is as to why you're making the conclusion that you've made. And it's going to be using just those 3 theorems that we learned today. Okay, write yourself a summary after you finish this. Go back and get your essential question filled in, and we will pick up next time with parallel lines and triangles.